In algebra, when we want to find the power of which a smaller number goes into a bigger number, we use these things called logarithms, or logs for short. Now the formula for the most basic logarithm is written like this. Log base A B equals C. Now let's plug in some numbers. Let's say we have log 5 25, and we need to figure out C. So, a log is finding out in the power of which this base goes into this number right here. So, since this is a simple this is a simple problem right here, we know that 5 times 5 equals 25. So, you're figuring out the power of which this number, A, goes into B. So, we know that 5 squared equals 25. And the C is the power of which this number fits into this number. So 5 squared equals 25. So log 5 base 5 25 equals 2. So next, let's solve this another quite simple logarithm right here. So log base 2 32. So again, we're finding out the power of which this 2 goes in to this 32 right here. So, how many times does 2 go into 32? Well, we know 2 times 2 times 2 times 2, it's 4, 4. That is 16. And then 16 times 2 equals 32. So we can add on another 2 right here. So that was 5 2. So 2 to the power of 5 equals 32. So log 2 to the power of 5 equals 32. So our answer right here would be 5. Now let's say we're given this problem. Log base A 16 equals 4. In this case, they are not giving us the base, but they do give us C, which is the power of which this number goes into this number. So, write it out. Rewrite it as A to the power of 4 equals 16. Since these are fairly small numbers, we know that 2 to the power of 4 equals 16. So we would rewrite this log as log 2 log base 2 16 equals 4. Now as we tackle bigger and more complicated logarithmic problems, there are 4 properties that come in hand when solving these logarithms. There are 4 main properties. These properties include power, the power property, the product property, the division property, and the change of base property. First, let's start with the power property. So, writing out the formula for the power property, we have, let's say we take another simple logarithm, and we'll just use letters this time. Log A B, but then to the x. So this number goes into this number times this number. But since we can't solve a logarithm with this variable in here, what we do in the power property is we move this x, which is to the power, we move this x out here. So this, in the power property, this entire thing is rewritten to the power log base A B. Now let's add in some numbers. Let's take log base 4 3. Now in order to solve this log, we cannot have this 3 right here because that messes the relationship between these two numbers up. So what we need to do is move this 3 out here. So this rewrites to 3 log 4. We now simplify that down to 3 times log 4 of 4. Now going back to the beginning, 4 times what number, or 4 to the power of what number is this? 4 to the power of 1 equals 4. So this would rewrite to 3 times log 1, which is just 1. So 3 times 1 equals 3. The answer to this right here is 3. Now the second property of logarithms is the product property. And what the product property is when we are trying to add two different logarithms. So the formula for the product property looks like this. Log A, base A, B, plus log A, still the same base, remember that, we keep the same base, plus, since it's a different log, B, and we'll call this log base A, C. So now, what we do is when we're trying to add them, is we take these two, B and C, and we multiply them together. So this would look like log base A, remember, we have the same base, so log A, B, C. So let's throw some numbers in. So, for example, we have log 2, 4, plus log 2, remember, same base. So we have log base 2, 4, plus log base 2, 8. So, we multiply these two variables. So this would look like log 2, 4 times 8. Or, simplified down, log 2, 32. So, going back to the original logarithm, we would see our answer would be to the 2 to the what power equals 32. So we had the same exact one for the original one I showed you. So 2 to the 5th equals 32. So the answer for this entire thing, log 2, 4 plus log 2, 8, would be 5. Now when we wanted to add two logarithms, we used the product property. Well, what happens when we want to subtract? When we want to subtract two logarithms, we use the division property. Division. Now what this looks like, let's just use letters as for our formula. Log A, B, same one, minus log A, C. Now instead of adding like product property, we're subtracting. So when we added, we multiplied these two variables right here. Well, in the division, we divide them. So this would look like log base A, remember we keep the same base, B divided by C. So our formula, subtracting, and when we subtract two logarithms, we divide the two variables, log base A, B divided by C. Now let's throw some numbers in. So we can do, we'll use some big numbers here. So we'll do log base 5, 625 minus log base 5, same base still, log base 5, 25. Now, when we want to subtract two logarithms, we divide these two variables right here, 625 and 25. So this would look like log 5, 625 divided by 25. So 625 divided by 25 equals 25. Now 25 isn't the answer to this. 25 is only the answer to 625 divided by 25. So what our log would look like would be log base 5 still, 25, because 625 divided by 25 equals 25. So we can even simplify log base 5, 25 even more. So remember, going back to the originals, what, the 5 to the power of what equals 25? And that's our answer. So, since it's a pretty small number, we know that 5 squared equals 25. So 2, right here, the coefficient, or the power right here, the exponent, as we call it, equals 2. Now for the fourth and final logarithmic property, let's say we have log base 2, 8. Now, 8 and 2 being pretty small numbers, we know that, going back, 2 to the power of 3, or 2 times 2 times 2, equals 8. So, we have 3. Now let's say we couldn't find this number right here. We couldn't find 3. What we can do is use the change of base formula. Change of base. Now how we use this is it's written like this. Log AB. Now what we do is we want to find this, but let's say it's a too big of a number. We would do, this would become log B divided by log A. Now let's plug these numbers in. We would have log 8 divided by log 2. And we would plug these log 8 and log 2 into our calculators and get 3. Now let's take log base 4, 70 for example. Now there's no way we would be able to figure out 4 to the power of what goes into 70, since these numbers have no relationship whatsoever when it comes to powers. So in order to figure this out, we would have log 70, since our formula is log AB equals log B divided by log A. So log 70 divided by log 4. And we would plug this into our calculators, and the answer we come up with is is 3.006641508. So 4 to the power of 3.06 4 to the power of 3.064641508 equals 70.